This is the representation of the kind of quality of speakers that we have here at West Hawaii Forum. And we put these monthly forums on to provide as much civic involvement and education on issues that are important to you, the community. We are one island. We are one community.
If any of you had an opportunity to read the West Hawaii Today editorial section, there's basically one line I want to read to you if you missed it. It reads, "Vital infrastructure that is poorly administered is a public hazard, and when it's our water system, that hazard is not to be taken lightly." So with that, we are here tonight not to take our friends at DWS and put them crucify them. We're here tonight to find out and answer questions on how we got here and what they're doing about making sure it doesn't happen again. And so with that, and I'm very pleased to also thank Mayor Harry Kim for coming out this evening to join the DWS crew. And with that, I'm going to turn it over to our moderator, Sherry Bracken. Thank you, Sherry.
Thank you. Aloha. I'm delighted to see everybody here, and of course, as you know, we're going to be talking about water, particularly the North Kona water system and its current state and restrictions that exist and probably will exist at least until December. We have the mayor here, as you can see, and the head of the Hawaii County Department of Water Supply, Keith Okamoto, and several members of his team. So we have the opportunity to get all of your questions answered. And what we're going to do is Water Supply is going to tell us what they know about everything that's going on and what their plans are, and then we will take questions. We have had a lot of questions submitted today from the website, the West Hawaii Forum's website. But if you do have questions, we would love to get them. Just write them out. If you need a card on which to write them and you don't have a card, wave your hand wildly in the air and one of the folks from the forum group will bring you one. And they'll also collect your cards and bring them to me, and we'll try to get as many questions answered as possible. Although the major focus today is what has happened that made us have 4 wells and then a 5th well go down, and what the status is of getting those wells all back in service. We're going to also ask questions about future development and how that's going to impact our water supply. We're going to ask about conservation and things like that. And you know, it's interesting. We in this county have not really worried much about water conservation. At least I haven't seen much concern about it. And that's something that we, as I've talked with Keith Okamoto before, I think we really do need to think about, even though on this island we do have a lot of water, but it's not always where we would like it to be. And I didn't tell Keith and his gang this earlier when I was talking with them, but you know, sometimes we all think we'd like to be younger. Well, I was thinking about when I was younger, I lived in Marin County, California, and in 1977, we had literally no water in the county. There were 3 reservoirs. They were completely dry. The reason for us having no water was a little different from this reason, but conservation became a way of life, and in most places it is. So I am going to ask Water Supply to address that a little bit this evening. Hawaii's water management is the responsibility of the State Water Commission, which is part of the Department of Land and Natural Resources. And although the state does have ultimate responsibility, they have turned over responsibility on this island in general to the Hawaii County Department of Water Supply. And we're going to talk more about the state because, as some of you probably know, we went through a lot of discussion about the Keauhou Aquifer, which is the water that is underneath where we're standing right now. One of the things the state told me at that time is on this island there's around 5,000 wells. There's about 65 of them that are controlled by the Department of Water Supply, so there's a lot of wells on this island. Now, our panel tonight, of course, you all know Hawaii County Mayor Harry Kim, and he pretty much needs no introduction, but let's give him a round of applause for coming all this way. Keith Okamoto is the chief engineer with the Department of Water Supply, and he's the manager of the Department of Water Supply. He started his engineering career working for private engineering firms on Oahu, and he's been here with DWS since 1996 in several jobs. He became the deputy in 2012 and became the head of the department in 2015, and he is the chief engineer. Kavika Uehara is his deputy. He started his engineering career working for private engineering firms in Seattle, Honolulu, and Hilo. He joined Department of Water Supply in 2007 as part of the Water Quality Assurance and Control Branch and became the deputy in 2015. He went to Waikea High School, so I'm sure you have lots of aunties and uncles who keep close tabs on what you do. Also went to University of Washington. Kurt Inaba here is head of the Department of Water Supply Engineering Division. And that is the division that has responsibility for the engineering branch, water resources and planning branch, water quality and assurance branch, land branch, and support branch. You have a lot of stuff to do. Yeah. And he went to Hilo High. He's been a civil engineer with the department since 2006 and started with the Department of Water Supply in 1994. Clyde Young is the lead mechanical engineer with DWS, and he graduated from UH with a bachelor's degree in business management and science in mechanical engineering. He's a registered professional engineer, and he's been with Department of Water Supply since 1991, and his main job is the repair and maintenance of all the pump station equipment, so you're going to be busy tonight because we probably have a lot of questions for you. I'd like to move right into the presentation. Keith Okamoto and his team will take it away. And just let me remind you, lean into your microphone and use your partly outdoor voice, please.
Okay, thank you, Ms. Sherry. I also want to thank Bill Bugby and the team. I know Jane Clement also with the team here with the West Hawaii Community Forums. Thank you for this opportunity. Letting us share some information with you folks. Hopefully, we'll make things a little clearer. That's our goal. First of all, I want to clarify that this situation that we're in with the wells being down is 100% the responsibility of the Department of Water Supply. Mayor Harry has graciously offered his support throughout, but the responsibility is really all ours. Our revenues come from, 100% of our revenues come from the water bills, the revenues from the water bills. So hopefully that does clear some things up. I know a couple questions were in that line. I also want to thank the community at this time for their patience and understanding, especially when that fifth well went down. With everybody's cooperation and support, we were able to manage to get by without anybody going out of service due to that fifth well being down. So again, thank you folks for all your efforts. It's truly appreciated. Mahalo. Okay, so basically, we'll start this off with a basic outline of what we'll cover tonight is what's the situation, how do we get here, what is being done, contingency plans, and looking ahead. Okay, so what is the situation? I'm sure some of you guys heard this before, but we have 13 sources in this system. 6 what we call basal sources, 7 high level. Right now we have 4 of the 7 high level sources under repair. And again, as we know, the 5th well went down at the end of June. Fortunately, we had spare pump and motor on hand, able to get that one back up and running July 5th. Current situation as of this morning, system is stable, tank levels are sustaining. So again, mahalo for your cooperation and your efforts. Some background on how we got here. Basically, we had the Hualalai and Palani wells were down approximately April, May of 2016. Hualalai we've been struggling with for the past couple years. The last two repairs, really, the well only operated for about 6 months before they went down. So the last repair, we did a major overhaul, basically. We changed the pump and motor, the pipe columns, the cable, the check valves in the pipe column, the transformer, major electrical components topside, pretty much regutted the whole thing. And even with that effort, 6 months later, it went down. So we're attempting to try and figure out really what the cause of failure of that well was when Palani Ranch well went down. And that one went down after approximately 10 months of operation. So another scratch our head moment. And the other thing that complicated that issue was the warranty issue. So basically we wanted to determine whether or not it was something that we could basically turn back to the contractor or the manufacturer and say, hey, something went wrong here. Let's investigate this. So those two wells were down about April, May last year. And then, so as the years went by, we're still trying to conduct our investigation to really see what went wrong with these two wells. Then in December 2016, the Ke'ahu'olu well went down. Fortunately, with that one, we had a repair contract already in place. Contract was executed. So we were able to get that one back up by the end of January 2017. But midway through January, before Ke'ahu'olu could even come back online, Waiaha went down. So that made the 4. And that's when we issued the water restriction because we had 4 wells out of service. So they didn't all go offline at the same time. It just so happened that they are currently still under repair. And as we experienced that Ke'ahu'olu well that was brought back online January 30th, at that point we thought, phew, okay, we only got 3 down, only. But then that one went down end of June, less than 5 months. So, it's something that we're trying to figure out what is the cause of failure. They're not all the same. As we go down with our presentation, Clyde will explain a little bit more about some of the technical aspects of our deep wells. But anyway, again, currently we're stable, even with the 4 wells down. Tank levels are sustaining. Everyone still has water service. Everybody, continues to maintain water service as we speak. And at this time, I would like to turn this over to Kurt Inaba, our engineering division head.
Okay, so this is just really the map of the North Kona water system. It does cover basically from Makale Fire Station up on the north end, on the Malka side down to Keohole Airport, and extends south to about Tashima's, and on the Makai side, Keoho Resort area, just past Mauna Loa Village. So the sources are labeled there, maybe starting from north to south, are the Kalawa well, Hualalai well, the Palani Ranch well, Honokohau well, the Keohu'olu well, and the Keopu well and the Waiaha well. So those first 7 from north to south are actually our high-level, higher quality sources. The 4 of them are out, again, are the Hualalai well, Palani Ranch well, the Waiaha well, and the Keopu well. The other 6 sources are basal sources, and they are Holualoa. We have 4, sorry, I would use a pointer, but I think it'll be too shaky for it anyway. But we have 4 Kahalu wells, A through D, and we also have the Kahalu shaft. So a little bit of background on the entire North Kona system here. The first wells, Kahalu A and B, were actually drilled in 1959. And the shaft was constructed in the mid to late 70s, and the shaft was expected to provide, or intended to provide us 10 million gallons of water per day. And today we know that we want to max it out at about 2 or 3 million. Reason being, as the sources as we started pumping the sources more, the basal sources back then, the chlorides also started rising in the source itself. So that resulted in the exploration of our new higher quality water, or a better source, which by chance was found up around that 1,700 foot elevation. So that there, I think in 1990 anyway, was the first of those wells were drilled. Okay, no. So yeah, once the higher quality water was discovered, basically the efforts switched. So the state, DWS, and as well as developers all then had to switch to, looking into developing the high-level sources and implementing that to actually supplement the basal sources. The main challenge has been really, the original system was built again with the basal sources, and they're located at lower elevation. So the intent at that time was to provide water basically from south, because it was in the Keho area, to north, where the anticipated growth was, as well as pumping up only the amount of water that is needed or was planned to be used up on the upper section. And because the majority of the growth was anticipated and the actual use was occurring in the Makai section, the Mauka infrastructure was much smaller. So now that we know that the source is available up in the Mauka area, we have to reverse all of that infrastructure, basically put large capacity infrastructure up Mauka. So just in the past 10 years or so actually, department spent 45% of our CIP budget in the North Kona system, which is approximately 40 million out of 90 million island-wide. We are continuing to improve the system. Right now, we have plans to add 2 additional sources as well as transmission lines in our current CIP. And we also continue to collaborate with other agencies, other entities to create public-private partnerships or multi-agency partnerships that we can help improve the system together. So looking ahead, really, we are trying to do our best to learn from both our successes as well as our failures, yeah. We want to become more reliable and more resilient, so we need to continually adjust basically our water system improvement guidelines. For instance, we found that in the past we've now dealing with some of those deep wells, the high-level wells, with casing sizes as small as 14 inches and trying to fit these very large pumps down. That really limits the availability of motors that we can actually fit down the hole. So we're, new construction, we're making sure we have adequate size casing. Right now we're looking at a minimum of 18 inches to ensure that we have the availability of different motors that can actually get sent down to that, down in the hole. We're also looking at utilizing little smaller horsepower motors, 400 horsepower max versus what we have out there now, 600 or even 700 horsepower motors, as well as limiting the pumps to 700 GPM. And this is really by looking at our past records, has proven to be more reliable, have less failures for those equipment. And we're also looking at, with the smaller capacity well now, putting 2 sources on a single site. So if one goes down, instead of losing 100% of our source capacity at that site, we hopefully will be able to keep 50% at least, yeah.
Interrupt 1 second.
Sure.
If you make the size or the volume available from the well less, is that going to still provide enough water to serve what it needs to serve?
It will if we are able to put 2 wells on that one site. So looking at the site as really a source, a single source, but if we have 2 pumps and motors down, it's kind of like, I think it was explained before, like having a big straw in a cup, or you can put 2 smaller straws in that same cup. to get out the same amount of water. What we do is when we drill the well, we have to pump test it. Interference is okay, provided that you plan for that actual interference. Especially with two smaller straws, you have less drawdown, what it is when you start pumping the water up. And we're also looking at other equipment to help better protect the actual pump and motor that's going downhole. We're looking at things such as a variable frequency drive, which limits the on-off cycling of the motor. So when we don't need as much water, it'll slow down, pump less water. But what it does, again, the on-off cycling, think of like a light switch clicking on and off, that typically accelerates the wear and tear on both the electrical and mechanical components. So trying to avoid that as much as possible. And again, we do have to evaluate in our future needs the overall system, not just the source, storage, transmission, boosters. That will give us the additional capacity as well as the flexibility that we need to move water, interconnectivity basically. We also know that we need to continue to monitor our sources for long-term sustainability for both quantity and quality. And we also, are looking forward to sharing that information because there are a lot of other studies out there that's going on, very important studies regarding our resources. So we need to apply what we have learned, throughout all of this to our new facilities as we move forward. So with that, I want to turn it over to Clyde.
Okay, so yeah, we know that map is kind of hard to see, but we'll make this PowerPoint available to everybody. I'm sure Bill will be able to assist us with that. But basically what that map shows is the amount of improvements, capital improvement projects that have been completed and also that are in process, and a couple of future ones too, yeah, Kurt? Or is that just a...
Future ones and, couple of future ones that actually you're not on there yet.
Okay.
This is basically taken from our Water Use and Development Plan update that
Okay.
we just finished.
So this shows the approximately $40 million in capital improvements
Yep.
that has been done in the system over the past 10 or so years.
Excuse me, I'm getting over a little bronchitis, so if I start coughing, please forgive me.
Kurt just moved way away from you.
I'm not contagious, so if you shake my hand, I'm not contagious. I'm the lead mechanical engineer. My primary responsibility is repair and maintenance of all pumps and motors, electrical equipment at all of our pump stations island-wide. I want to recognize my right-hand man, Eric Takamoto, if you can raise your hand. He's involved with the day-to-day. Okay. He's involved in the day-to-day management of a lot of these repair projects, so I totally rely on them on that side. And I just wanted to recognize him. Okay. I just want to say two quick things before I start my presentation. Our goal is to make sure you guys have water 24/7, 365 days a year. And, I take pride in that. And if it doesn't happen, I'm extremely disappointed. Okay, I also wanted to say, I consider it an honor and privilege to be working for the department and also being able to serve our community. So I just wanted to, let you know, I'm part of the community and I wanted to. Okay, so I'm supposed to give you guys the repair updates on the 4 major wells that are down. Waiaha, completion date is scheduled for July 31st. So all those dates on the right there reflect contract completions. Those aren't what's happening in the field. So as of today, the Waiaha well, they're actually doing the repair right now. They're on site, putting the pump down the hole. We're shooting for July 31st. If they don't meet that July 31st deadline, the contractor's facing liquidated damages. But so far, so good. If all goes well, we're shooting for July 31st. So that's going to be a big help. That well can put out 1,400 gallons per minute or 2 million gallons per day. Now, the Palani, Hualai, Keopu wells, they got October, November, December. It is our hope that, working with the contractor and the pump and motor manufacturers, they've committed to put ours up in queue. So That doesn't always happen, but in this case, it looks like it's going to happen. So we're pretty optimistic that we should be able to get those completion dates significantly earlier than the dates that are up there. That's what we're shooting for right now. I want to give you some, just a little bit of pump basics, because when I explained what's happening and some of the issues that we face, I thought I'd have to give you a little bit of background. For example, what is a pump? I'm not going to assume everybody knows, but basically a pump is a device that moves a fluid from point A to point B. In this case, water, usually from a lower elevation to a higher elevation. So we have two types of wells, what we call a submersible right here, and this one is what we call a line shaft. The difference between the two is the location of the motor. So in this case, the motor is located topside. Okay, so anyway, the motor's on top, the pump is down in the hole, in the well. In the case of the submersible, the motor is located down here and the pump right here. So the motor is sitting in the water, that's why they call it submersible, and the cable, they run a power cable up. To be able to turn the line shaft pump, they have a line shaft or a shaft that goes all the way down the well. Now there's limitations where we can put line shafts. Usually, typically, we have to keep it under 1,000 feet. So it doesn't apply to our deep, high-level wells that we have problems with right now. Okay, now I got another picture over here that shows a little more detail of a submersible pump. And this is a little bit of show and tell. Eric's going to help me with this. This being the submersible motor, the strainer. I actually can't read it from here, but I know it by memory. This is a strainer. This is where the water comes in, and then it goes up through the impellers. You want to show what an impeller is, Eric? Relatively small impeller, 4-inch, and Erica also has the pump bowl. The impeller sits in the bowl. Okay, so in our case, most of these wells at the high level, they're 10-inch, so they're about 2.5 times the size of what you see here. Please don't drop it. It could hurt your feet. It's fairly heavy. The ones that actually are in the wells that we have. These are actually real pumps. These are just much smaller.
But tell them how much bigger again.
Yes, 2.5 times bigger. So those are 4-inch. The wells that are at our high level are 10-inch. So significantly larger. Okay, anybody else want to look? We also have the submersible, a sample of the submersible cable, and we'll leave it up there if you want to see it later. And we also have a sample of the casing. The casing is located in the well. That's the power cable that runs down through the well, all the way to the motor, all the way to topside to our motor controls.
And that's not the actual size, or it is?
Yeah, that's a smaller size. That's about half the size of the cables that are up at our wells. Okay, Eric's going to show the well casing. As mentioned earlier, Kurt mentioned that we're going to a minimum 18-inch. The wells that we have in the North Kona system on the high level, they range from, I believe, 16-inch to 20-inch. So this is an 8-inch. So double that size or even bigger. Okay, this is a perforated casing. Okay, if there's three things about a pump. Now I said it moves water. The three things, if you want to know what a pump does, the three key words are head, flow, and efficiency. So head being the pressure, flow being the gallons per minute, and the efficiency is related to power, how much power it takes to run the pump. So, because we're going to come back to that, and that's the key to figuring out, how do we make the well work? Are the pumps interchangeable? Can we have spare pumps? What are the factors that we have to look at? And the three key things are the head, the flow, and the efficiency. They all get impact. You change the head, all the other two parameters change. Okay, in the case of the high-level wells, they were all submersibles. Okay, this is what it looks on topside. We have a couple photos here. This one being the submersible, and this being the discharge head. So this is the equipment, what it looks like coming out. So the water comes out and follows this pipe. This is the line shaft, as I mentioned earlier, the line shaft, the motor sitting on top of the wellhead right here. And this is the discharge piping. Okay, as I mentioned, line shafts are limited to 1,000 feet. Okay, next slide. Okay, here's a couple photos during the repair of our Keoholu deep well. In this case, we had a 4-pole or what we call 1800 RPM pump repair. Each little shape here represents a pump bowl, same as the one we just shared, right? This one has, I believe, about 29 stages. And basically just the photos of the pump rig as they're installing the pump. I think this is an install. Okay, so there's 1,600 feet in this 600 feet of column pipe. I'm sorry, 1,600. That's about a quarter mile of pipe, 10-inch. The weight of the pump and motor and the column pipe is 36.5 tons. I was trying to relate that. What is 36.5 tons that you might relate to? That's about the weight of a humpback whale, adult humpback. So I couldn't think of anything better. Sorry. Okay, and then you add the weight of the water. The weight of the water is about 27 tons. So large forces, 27 tons. That's about the weight of a teenage humpback. So, yeah. I love water. Okay. Okay. One of the big questions I keep hearing is, and I'll try to explain, why do the wells take so long to repair? So, now the key words was, that I mentioned earlier was head, flow, and efficiency. But let me give you a little bit of timeline of what it takes to repair a well. Okay. So, once the job goes out for bid, we give the contractor notice to proceed. It typically takes 1 to 2 months just for the manufacturer to sit it in queue. We get put in line with everyone else. So right off the bat, we have to sit in line because the manufacturers for the pump and motors, and they're all on the mainland. Everything has to be shipped in and out if we have to do anything. Large pumps. It's not something we can just buy off the shelf. They do have submersible pumps and motors that you can buy off the shelf, but they're usually limited to much smaller sizes, typically under 150 horsepower. Now, a lot of these wells are, I think the smallest one we have was the Keopu is 400 horsepower. So we're not even close to the sizes that we need to have to just buy it off the shelf. Much smaller pumps, much smaller capacities, 200 GPM. We're up in the 1,000 GPM, or more. Okay, so it sits in queue for 1 to 2 months. Then when it does get into a manufacturing process, then it takes another 3 months. So now there's a lot involved in the manufacturing process. Sometimes you have to pour castings, trim impellers. Now I don't want to get into the details of it, but basically it takes about 3 months. So right off the bat, that's about 4 to 5 months right there. Okay, then it goes through a testing process and approval. So when it goes to the manufacturer, they test it. We review the test results. We want to make sure it's meeting spec, because pumps, when you buy them, they designed specifically for head and flow and efficiency. We're trying to our goal is to maximize the efficiency of the pump, so we use the minimum amount of electrical power. Okay, so after you go through all that, and sometimes it goes backwards. Sometimes we don't approve it because they don't meet our specs. Maybe say it requires an 80% efficient pump, and they give us 76. They have to go back until they get it to 80%. So, those things can delay the process also. Then there's about 1 month just to ship it out from the mainland, typically. Slow boat. Goes through Matson on the west coast. They truck it across the mainland, and then we have to inter-island barge it for Honolulu. So about a month. And then you have the installation. So typically another month, which includes testing, installation, push-pull. Push-pull as in pulling out the old pump, putting in the new. So on a typical repair, it's not unusual to take 6 to 9 months. So understandably, it's a relatively long process. Okay, next slide. Okay, now this slide might be kind of hard to read. It's a little small, and forgive me on that. I'll try to explain it to you. It's similar to what Kurt put up earlier. Basically, these are all the wells from north to south, basically. So you might be looking at Kalawa and all the way back down to Waiaho and Keopu. Okay. This is, now what we got to pay attention to is really the length of this vertical piece here. You can think of it as a straw, but that relates to our head. Now, if you notice, they're not all the same length, and this blue area indicates where the water level is, right down in here. So different lengths, which reflect pressure, the different pressures. As I mentioned earlier, the key is pressure, flow, and efficiency. So they all affect each other. So one of the big questions that came out was, why doesn't the department keep spare pumps? Well, we do keep some spare pumps. A good example, as mentioned earlier, was the Keoholu repair. We were able to fix it in 7 days. But to have spares for every single well, 66 wells, that would be quite expensive. So what are the challenges? And that's basically one of the bigger challenges, finding a balance on cost and making it and having it available. So one of the other challenges is, if it sits on the shelf for a year or two, I think we're pushing for 2 years, but typically we only get 1 year from the manufacturer. We've been pushing for 2 years, so we, because a lot of times these pumps will sit on the shelf. But if they sit on the shelf too long, a couple things happen. One is we primarily lose the warranty. So obviously we don't want to lose the warranty. If it really sits on the shelf for 4 or 5 years, then the parts start deteriorating. So, you're spending, on these larger wells, it's not unusual to spend $250,000 for a pump and motor. That doesn't include all the other costs that are associated with a repair, but that's just the pump and motor. So if you're looking at, 4 or 5 large wells and you're trying to put inventory costs, you can easily exceed $1 million. So it's not cheap. And then if you don't use it, you basically have to take the pump and send it back to the mainland and get it refurbished. So then you got to go through that shipping process, additional delays. So, so that's why we're trying to balance, if you do every well, there's a good chance you're not going to be able to use all the wells, the spare pumps. Okay. There's also the challenge of storage. Ideally, you want to store it vertically. As I showed you on that one photo, that 29-stage pump, and that's over 30 feet tall. To store something that tall vertically, it requires either a very deep pit or a very tall building, and which we don't have. So we store all the pumps horizontally. So that affects the longevity of the pump, because when you set something with a shaft in it horizontally, the shaft will tend to bow over time. So it has to be pulled, sent back to the main, shaft straightened, and check for seals, check the bearings, make sure there's no corrosion. So there's a cost associated with keeping that inventory. Even if so, in a perfect world, you use that pump right away, but that's not good because that tells you that your pumps are breaking too. So okay. Another question: how about so if you don't have a spare pump for every well, how about interchanging or exchanging pumps? Put the Keoholu well in the Honokahau, or put it in the Waiaha or the Hulalai wells. So we looked at that. There are challenges. As I mentioned, those straws, which represent really pressure, you changed one parameter, you're going to affect the other two, and usually not in a good way. For example, I'll give you an example, like Honokahau, one of our larger high-level wells. If we put a pump in there where the head is a little bit different, we just get maybe a 5% change in pump efficiency. That equates to about $60,000 per year in additional electrical costs. So, and that's per year. So the life expectancy of a typical pump should be in the range of 4 to 7 years. So you got all this additional electrical cost you got to pay. So but if we got to do it, we're going to put that pump in there. If it means you not having water, we're going to put that pump in. That's just a cost we're going to have to bear. But there are, it's not just a simple, yes, this pump will work. There's a lot, matter of fact, there's other issues. Even if that works, what are the other issues? Well, one, can it fit in the well? You know, some of the pumps are bigger. You know, as I mentioned, some of the casings are smaller, so you can't fit, you know, an 18-inch pump and motor in a 14-inch casing or a 16-inch casing. So, you know, some logistical issues we have to resolve. Do the motor voltages match? You know, some of the motors are 4160, 2300 volt. You can't just mix and match that. Equipment's set up for that particular voltage. Do the pumps and motors match in speed? You know, some we have, I mentioned a little bit about it a little bit earlier. There's 2-pole and 4-pole. They represent two speeds, basically. One is 1800 RPM, the other one being 3600 RPM. You can't put an 1800 RPM pump on a 3600 RPM motor, for example. Or you potentially overload, okay? And obvious, as I mentioned earlier, the loss of efficiency, higher electrical costs. If you're not operating in the proper area of the manufacturer's recommendation, you also risk damaging the pump or the motor or both. So there's a narrow range, typically within 10% of the operating, best, what they call the best efficiency point. You know, the manufacturers say you need to operate in this narrow range. If you don't, you risk getting vibration, upthrust, all kinds of other issues potentially. So all these things got to be factored in. So there's a lot of challenges on trying to figure out. We're looking at all different kinds of scenarios of where we can, you know, exchange pumps and motors. It's much easier to probably have spare motors, you know, and us standardizing maybe the motors to a speed and voltage. You know, that's one of the easier things that we can possibly do that we're working on currently. Okay, well, the last question. What is the department doing to improve pump reliability? You know, obviously one of our challenges is trying to find out what's causing all these failures, and it's been very difficult at best. You know, we talk to manufacturer reps, we talk to pump engineers, and you know, I've been sent to the mailing for pump testing. You know, I run these questions, and it's, you know, when you have all these different types of failures, it's hard to nail it down to, hey, we just have this one, let's fix it, and it takes care of all the wells. When you have all these variations of the theme, it makes it hard to nail it down. So we are doing a bunch of things to try to mitigate those factors. As Kurt and Keith mentioned earlier, we're looking at going to smaller wells. There's one thing we know, though, the smaller wells seem to last longer. You know, maybe, you know, you get less loads on the pump and motor, basically. You know, I might be oversimplifying it, but we don't know why, you know, but we just know what happens. So that's why we're looking at multiple wells versus a single big well. Okay, so some of the things we're doing, we're currently in the midst of a power system study. Excuse me. We're testing all our electrical equipment, well, mainly the main breakers, and we also have another job going out related to that, and they're looking at, we're gonna look at all our topside electrical equipment. I'm not an electrical engineer. I don't have an expertise in that area. We don't have one on staff. So we're gonna bring an electrical engineer to help us look at that, look at our equipment, and make sure we got proper protection. If we're weak in areas, what can we do to fix it? You know, some of the other things we're doing, we're looking at our surge protection. You know, do we have problems with lightning strikes or, you know, surges coming from our local power utility? I think we have our utility representative over there. But there's a lot of causes for surges. You know, it could be an accident on the highway. They hit an electric pole. You know, as I mentioned, lightning. As mentioned earlier too, we're looking at VFDs. We're installing more of those. We're trying to. What was that? I'm sorry, VFDs, variable frequency drive. Basically, a variable frequency drive allows us to run the pumps at different speeds, and also gives us an advantage of being softer on our mechanical and electrical equipment. It has a nice soft start and a shutdown, so without shocking the system electrically and mechanically. So we're looking at that to improve reliability. There's a lot of other benefits, but that's primarily the primary function. We're looking at improving reliability. We're looking at installing power monitoring. Now, power monitoring is not going to necessarily help us directly with reliability, but it's going to help us troubleshoot looking at electrical quality power quality issues. You know, you know, for example, we can do waveform capture. You probably don't know what that is, but basically it allows us to look at what's happening in very good detail in terms of what's happening electrically at a pump station, especially if we lose a motor. What caused it? Was it a lightning strike? Was it something from the utility? You know, was there a car accident or whatever else could cause a surge in the system? And then finally, we're possibly looking at maybe power conditioning. You know, I think the one way you can relate that is maybe like something similar to a UPS, where, you know, it maintains a nice steady voltage to your equipment, so you don't have all these voltage dips or spikes. You know, it can help mitigate some of those issues. So we're looking at that also. Okay. I think that's enough for the technical side. I hope I didn't bore you to death.
Actually, I understood a lot of what you said, and I appreciate it. You have the ability to break down what you do to something that maybe lay people can get, so thank you very much.
Okay.
Yep, thank you, Clyde. I just wanted to recap some of our public outreach efforts that we've been employing since January this year and through to the current situation right now. When the water restriction started in January of this year, we sent out notices via West Hawaii Today, also radio ads. We coordinated with Department of Education to disseminate the message through the students. We also teamed up with fellow county agencies such as Civil Defense to send out radio and text messages. Other government agencies we worked with, such as DOT Airports, NELHA, DLNR, Honoka'a Harbors, all helped get the message out about the water restriction. Other methods that we used was also the variable message signs. You guys probably seen them alongside the roads, displaying the messages. Sent out letters to all customers, followed up by letters to certain high users. Also phone calls to the high users. Civil Defense helped us with that. In late April of this year, we also had some face-to-face visits, some of our higher users, to educate them and to inform them of the situation. We also put a bunch of our information, notices, and frequently asked questions on our website, and we continually update them on a weekly or routine basis. When the emergency water restriction occurred in June of this year, we also increased our presence and had personnel following up on reports of wasteful water use, and we addressed those in person. We wanted to also say mahalo to Sherry and Hawaii Public Radio that we also used their media to disseminate information and messages and more notices. And we're always looking for ways to improve how we get the word out there. So by all means, if you have any suggestions, or a condo association or homeowners association or any other community group that you feel you would want to be added to our contact list, please see myself or Kaiulani Matsumoto, who is our information specialist, after this, and we can get your contact information. And so when we send out mass notices, basically, we can add you to the list. Contingency plans. So currently we have the 4 wells down. So what is our department doing now to plan if it gets worse? If we were to worsen, similar to what happened in June when the 5th well went down, we would send out emergency water restriction notices via radio, text, whatever means we can get it out there. Similar to the end of June, we would shut off temporary water accounts. Those are typically used by contractors for construction activities and irrigation accounts. We would install flow restricting devices on our high overusers. We would deploy water tankers and install emergency spigots, which was also done at the end of June. We are currently in the process, and we've completed a process of evaluating our overall system, North Kona system, to make sure we minimize any service disruptions if this were to happen. We also work with Civil Defense to issue a request for information on RFI to HIEMA, which is Hawaii Emergency Management Association. Basically, the RFI is kind of a query out to the nation, seeing if there are any other partners out in the nation that may have pump and/or motor that would meet our technical specs for the wells we have in Kona. We also would work with the mayor's office, and in the event that a state of emergency needed to be declared, we would discuss it with the mayor's office. My understanding is that declaration would then allow additional resources such as county, state, federal resources to be made available to us. Okay, so in summary, as we move forward, we're looking strongly on how to improve our service to our customers, to you, our customers. As Clyde mentioned a little bit earlier about our spare pump and motor program, we've actually initiated a bid process to evaluate our sources island-wide and come up with a priority list of which sources we need backups for. We've done that. We procured a first group of it. One of the wells, or one of the spare pump and motors in that first group includes a Honoka'a well for this region. The criteria that we looked at for this creating this priority list is if by chance there was a motor that could be interchanged with other motors, not necessarily the pump, but at least a motor. That was one criteria. Another was if that well was just a single source to the system. We have 23 water systems island-wide. There are some systems, Hamakua Coast, that only have a single source. So that also is evaluated in our decision-making process, or the grouping process. And the third criteria was if that well source fed a critical facility, such as a hospital. So we are working on that program. The spare pump and motor program, we've procured with that first group. We're now going to start working on the second group of spares. Okay, equipment options. As Clyde was mentioning, we've started the process of installing variable frequency drives, VFDs, which they explained, helps to lessen the wear and tear of our motors. We also have as Clyde mentioned, our island-wide power system study ongoing that'll help to evaluate our topside equipment, and if there are any areas of improvement for our topside equipment, hopefully that study will reveal it and we can implement those changes. Also, installation of power monitoring devices and power quality devices, as Clyde mentioned, equipment topside that can help to make sure we have a good, clean, stable power going to our motors. Looking forward, well construction standards, as both Kurt and Clyde mentioned, looking at the 2 straws versus the single large straw, trying to relook at that and make sure we have better redundancy and resiliency in our well systems. System evaluation, I think Kurt mentioned this too. We're doing a system-wide from our source to our storage, transmission line, booster pumps, do an overall evaluation and see where we have opportunities to improve our redundancy and resiliency for the overall system. And outreach and education, we are, maybe about last year, we started on a customer engagement program. Basically, in outreach, we contracted a consultant to help us get educational material about water conservation, efficient uses of water out to North Kona, South Kona, and our South Kohala system. We're also going to work on our island-wide water conservation, island-wide water conservation program, which is going to be heavily involved in education and getting out into the communities, such as the schools, to educate and to bring awareness to water is our most precious resource, our most precious natural resource, and it needs to be used wisely and efficiently. And that's part of our educational outreach. In addition to that, the outreach, being able to provide resources on low-flow fixtures and also drought-tolerant landscaping. I think we call it xeriscaping. Basically, landscaping that can flourish in a more arid environment. Let's see. So that's a snapshot of what we are doing and what we're looking forward, how we can better improve ourselves in our department for our customers and the community. And with that, that's it. I turn it back.
Yeah, so again, thank you, everybody. So if there's no further questions, we'll see you folks down the road. No,
Keith knows me better than that.
right.
Kavika, I have a question. You mentioned irrigation accounts. What are irrigation accounts?
Correct me if I'm wrong, but those are irrigation meters that are specifically agreed to be used for irrigation only, not domestic, right?
Well, like, who would have those? Like resorts or,
Condominium property.
okay. Did everybody hear me? It said resorts, condominium properties may have irrigation, and that's all they do with it.
Yeah,
Okay.
versus potable.
All right.
domestic.
Well, we do have questions. I know that shocks you, Keith, because you thought you had a date. Many coming in, as I said, through the website, many coming in here. This is the rainy season for Kona, and for example, last night, most of us who live in Kona had a ton of rain. One of my friends said her gauge showed 4.5 inches. Do you have the ability to collect rain into your holding tanks and use the rain that is falling naturally? Because summer is our rainy season.
Right, yeah, that's a good question. Actually, we don't. And the reason for that is because that introduces surface water influence on the system, which is in violation of the Safe Drinking Water Act. And that would require designated treatment facilities with a designated treatment operator. So although it seems to be a simple solution, that's not a solution that we can implement and be in compliance with Safe Drinking Water Act rules. So sorry.
If you have a reservoir.
Kavika has an opposing viewpoint.
No, it was just
No,
on
no, no.
top
Okay,
of that.
just
It
checking.
was on top of that.
We always like controversy here.
Yeah.
Obviously, and you mentioned that there's some large water users. One of the questions that came up actually from County Council member Karen Eoff at the Monday presentation when you spoke with the County Council was to help folks understand. Right now, we have some golf courses like Kona Country Club and Kona that are quite green. Why is that?
Kurt, you want to address that?
And sure. So those golf courses actually are not using our water or not using water from the Department of Water Supply. They have their own sources, and some of them, like Kwanaikia, even do their own treatment on their own water.
And I double checked with Kona Country Club this morning, and they do have wells that pump brackish water. So I confirmed. And I know Kona does, so that's interesting and good. What about other fairly large users, hotels, for example, like the Sheraton Kona and King Kamehameha Hotel, organizations that aren't residential users, probably use more than we do? What are you doing with those large users? You mentioned Natural Energy Lab in your presentation. How are you working with them to get them to reduce use right now when we need them to?
We were assisted by Civil Defense in calling, I guess, a list that we created of the high volume users, requiring their compliance as best as possible. And we actually did get improvements. NELH, they've implemented some system process changes apparently that reduce the amount of water that they use by over 25% is our understanding. As far as the hotels, basically we're asking them for best practices if, they could serve water only upon request and things like that. So we'll be following up with them on those efforts as well.
What's the possibility? By the way, some of the questions that came in are, I would consider, fairly technical questions. A lot of the questions are more like these, which are non-technical. So I'm asking more of the non-technical first, and then we'll get into the technical. But what's the possibility of bringing over water during this time from East Hawaii, since clearly they typically tend to have more water than we do in West Hawaii? And actually not just now, but at any time, reservoirs then pipe it over.
Right, so that's an inquiry that comes in every now and then. And so we've just recently did a preliminary evaluation engineering study on what it would take. And at this point, that option is really not feasible. Kurt might be able to provide some more details, but that would be a long discussion in itself on why it's really not feasible at this time. And if somebody really has that concern, we can talk story with them on the side.
But just give us a, I referenced, I think I referenced it, Marin County in 1977, they built a pipeline across the Richmond-San Rafael Bridge. The impact was, of course, there was one lane of the bridge closed down. That was unpleasant. But the other impact was the water rates for Marin County obviously became sky high. Is cost the reason why water wouldn't be piped or shipped over in some way, or is it more
Cost,
than that?
just bottom line, cost is always a factor in the decision-making process. So that one, I think alone, just in capital costs for that one was in the range of what, $500 million? Just
Yeah.
not including land
hundreds of
acquisition, environmental concerns, planning studies and things like that. That was just basically an infrastructure cost estimate.
Not
Real-
including the pumping costs to get it up
Electrical costs,
over,
correct.
yeah.
Yeah, we don't have that kind of funds.
Well, you do if you raise our water bills a lot, and I guess that's what you're trying to say.
Thanks, Sherry.
Clearly, we're in a crisis where we need to get this work done. So the question is, and I think from everything you've said and from what I've learned, is Hawaii County specifically, like Mayor Kim, does not control your budget, that you control your budget. So are you having your teams work overtime to get this work done? Tell us more about that so that we can feel comfortable that the urgency that you're expressing to us is the urgency that you also are feeling.
Yeah, so basically this situation, we got all hands on deck, all available resources is focused on this effort. The work doesn't stop. We got, like Kavika said, we got 23 systems around the island. We can't completely ignore them, but Eric's put in a lot of OT, Clyde has put in a lot of OT. The last well repair, we had the contractor do two 10-hour shifts, which is part of the reason why we could get it done in a week. So wherever we need to, we have that commitment to get these wells back up and running as soon as possible.
One of the reasons we asked Mayor Kim to be here was really having to do with the urgency issue. You mentioned that you had folks out going in the neighborhoods and looking for people who were doing things like watering during the daytime or using what you felt was excess water. Hawaii County internal procedures. On July 3rd, it was noted that there was a very large water leak in front of the Palani Road Fire Station. It was I think it's called a standpipe. And it turned out, this was Monday, July 3rd, the fire department had in fact called their management on Friday, the previous Friday, which I think was June 30th. The leak had been going on since the day before, Thursday, but there is only one county plumber. And so the procedure was the fire department guys told their management called the plumber. The repair was put on the list, but now it had been leaking for Thursday, Friday, Saturday, Sunday, Monday before somebody saw it in front of the Palani Road Fire Station, sent the video of it to you, Keith, and you, Kavika, and you immediately got somebody out there to fix what I would consider a really big leak. But so Mayor Kim, thanks to DWS for doing that, but in general, is there a way during this crisis that if there are internal county water leaks, that the procedure might be changed so that the leaks can be fixed a little faster?
Yeah, I will answer, I will answer that question, but before I do, I'm surrounded with 4 engineers, 2 on my left, obviously, 2 on my right. And I've been spending a lot of time with them. I'm not saying this to say it. I hope some of you, because of tonight's meeting, which I'm very grateful for, understand, number one, the complexity. Because every question you ask, I guarantee you, because of my previous job, I've asked also. Matter of fact, I think weekend before last, these 4 people was with me in a meeting on Saturday with a couple other of the staff. I say unabashedly that I am proud of your county Department of Water Supply. I wouldn't trade them. If you go check the problems of other counties or other jurisdictions, I think you will be too. And I think you can judge by their answer how complete they are. My job is to question, and I do question. In regards to things like Saturday in preparation for, this is a joke, so don't get offended by it. I told Keith after he called to say a fifth pump went down, I told him, you better go to church. Did you?
I prayed in bed.
But, seriously, they put in a lot of time. Their presentation, let's take a simple thing that I didn't know until I was in civil defense. To me, a pump is a pump. Then like your pumps here, they're down submersible about 1,600 feet. Just imagine a volume of 2 million gallons pumped up a day, the kind of technology that these people represent and require. And I think some of you are very surprised to find out how long it takes to order a pump. The kind of things we did on emergencies in that meeting Saturday, you set policies. If there is a fire in this affected area, fire department will immediately call civil defense to coordinate with water department what fire hydrant they can use without draining the system, because one simple fire, brush fire, otherwise you'll run out of water in no time if they drain that. And those are the kind of things. In anticipation for emergencies, the governor's office is contacted. We already drafted a proclamation of emergency, so there's no delay time. And the kind of things that you can do that he cannot do in a regular operation. Clyde, I think, explained how long it takes to ship the pump here because of size and weight. Well, that's where a declaration you can ask the military transport. Maybe it'll save a few days or whatever. Those are all the preparation kind of things that was done with them in regards to ensure what Clyde said, and in regards to make sure you get water 24/7 a day. And I'll tell you one thing about Clyde, he's not kidding when he said he's proud to work for the water department, and he takes very seriously the oath of keeping you supplied with water. The only thing I got a little irritated, and I'll say it, is because of accusation. I'm telling you, I'm proud of these 4 people, but in regards to other things of preparation of past emergencies, pumps were identified to ensure that if we have a hurricane, power is needed to pump all that water up 1,500 feet. So pumps were identified, generators were identified, specs were made to ensure you have a generator in case the power goes out to ensure that water is continued. All of this is things I learned in working with our water department in their prep as far as emergencies. In regards to listening to the question, I bug them with extra work, and I don't have the authority to do that, but they do that. I said, can you begin the study, because it relates to this question, can you begin the study to see how we can get water to Ka'u? I don't know how many of you know, Ka'u is on the southern portion of the island. The southwest portion of the island from Miloli, which is in South Kona, are all catchment. None of them have water. And the reason I told them to see what it will cost to transmit, because you can't dig wells there. There's no water. We dug a well at Hove and totally inadequate in quality and quantity, a very limited amount. And his assignment request by me was, can you figure out what it would take to get water to South Kona and the southwest portion of Ka'u? No water, zero. And another request made of him is of other places. Puna, volcano has no water. And I mean no water. So what we're talking about in round numbers of our people, your people, 30, 40, 50,000 people on this island that is on catchment. And I'm bugging him, same whoever asked that question. But this is the first time I heard the answer of $500 million or whatever, but that's only for one area. You talk about you take Lower Paradise Park. I would say 90% of the people don't have water because these were all substandard subdivisions. None of these statements are made to pacify you. I will openly say it. I love working with these guys. We got real professional people. You heard their answers. As far as the county government, our role is for fiscally to work with them on their budget. They control their money. We just review their budget. Other roles is make sure that, because they are government, sure all of the hiring practices, et cetera, falls in line with the regulations of civil service of government. So ours is basically a supervisory type. But during an emergency, there is no line between their office and our office. Whatever resources are needed, including the military, which was discussed, to ship over those pumps if necessary to save time, was discussed. And I promise you, we did draft declaration of emergency just to get it ready in case he didn't go to church and we had a 6-pump go down. I shouldn't make jokes like that, but we did work on the weekend to prepare all different scenarios. Thank you.
Well, Mayor, I actually concur that I've certainly learned a lot about water. In fact, when this first started in January, I was going to do a story for Hawaii Public Radio, and I was sort of puzzled why we would have 4 wells go down and why they had to be individually engineered. And so I talked to Riley Smith, who's with Palani Ranch, because I know he knows things that I certainly don't know. And he said, yeah, he explained exactly really what these guys have explained about the individuality of the pumps and the wells, the deepness, the steepness, all of that. And in fact, today I was talking with somebody with a water company in California to sort of check on these guys and say, you know, is this pump failure situation, is it a thing or is it just our thing? And they said, no, it happens because they're mechanical. But let's get back to the issue, Mayor. If, you know, we all are trying, I would imagine, I know everybody I know is trying to conserve water, stop their own leaks, and do that. Inside the county, is there a way that the county can set up a better procedure for now, that you do not have to wait for the one Hilo-based plumber in the county to come fix a county leak? Because 4 or 5 days for an obviously excessive leak seems like a bad idea when the rest of us are having guys drive around in their water truck, stop and give us not citations because they don't have the authority, but notices that we're not doing the right thing.
Okay, first of all, just to clarify, certain departments have their own plumbers and respond to their problems, like the Department of Parks and Recreation because of the size. And they do have qualified people in regards to plumbers to respond. As far as leakage, the reporting of leakage is a big problem. I think that we all got to work. I learned this from the Department of Water Supply. I'm sure at least a few of you have had leakage for a while and you didn't know about it. So openly, we encourage you to report any leakage that you see so we can follow up on it. In regards to the delay of response, sometimes bureaucracy gets to us, and there's no excuse for that. All I can say is, I think we'll emphasize more that anytime leakage is reported, that we got to respond to it ASAP. I've called Water Department because some of the responsibility is theirs because of the water line. Leakage is a problem, I think that will always be. Again, I make no excuses of it. If you can help us by reporting leakage that you know of, then please do. And as far as delayed time to get there, we'll try to expedite that in any way we can.
A question on water rates. Do businesses, hotels, golf courses, well, actually, all the golf courses are on private systems, so they don't pay the Department of Water Supply at all. But do businesses and hotels pay the same rate as do residential users?
So yeah, basically yes. We have a 4-tiered system, but it's all, whether you residential, commercial, it's a different amount based on your meter size for standby costs. But other than that, it's basically the same rate.
Maybe can
Yeah.
try the rate. It's a rate structure. So they have block rates for different size meters. but each of those blocks are the same rates. And the bigger meter you have, basically the block allows you to use more water within that rate. So the more you use, though, the higher amount you use, the rates get higher. So the third and fourth block rates go up significantly. Yeah.
So you basically are telling us we're going to pay more if we use more water.
Yep.
Okay, so you talked about large water users. Are you willing to share who the largest water user is in the North Kona water system? And what's being done to help them know that we'd like it if they use less water if it is an inappropriate amount? Because I would not know if it were an inappropriate amount or an appropriate amount.
Right. I mean, we're not real comfortable with singling out any of our customers, but we did take a look and compile a list of those that exceeded 10,000 gallons per day average. And there's about 135 of those accounts. So we reached out to all of those accounts. The top six, there's a top six that use greater than 100,000 gallons a day. So we've reached out to them accordingly as well. We're trying to figure out a way how to best approach communicating, because each of them have a slightly different situation. It's not a one fix for all type. So like Kavika mentioned, part of our conservation effort we want to lean on education first rather than something that's more, I don't know what the good word is.
Punitive?
Yeah, we like the encouragement part versus the hammer first. But basically, it's an overall effort, and we'd like to work with all of those entities because, I think we all, even on the west side, can probably do a little bit better. How's that for a chicken cop-out answer? I don't want to single out anybody. Everybody's got their own issues. I think we all can do better.
What's the average user, the average residential use per day? What do you think it normally would be? How many gallons per day?
Okay, thanks for that question. So I think apparently throughout this process, and what's the great thing about a difficult situation is I think information gets shared both ways. So we've learned a lot from you folks. Hopefully we've had an opportunity to share some and enlighten you folks a little bit. But it was quite shocking for us to learn that nobody was quite sure what their allotment was for their meter. So if you're on a residential household meter, a 5/8-inch water meter, basically the standard average daily use for that meter is 400 gallons per day, which most folks are. There's a few that are several times over that, so we're trying to figure out ways to work with them also.
I was telling Keith a little bit earlier that I was reading more about California's water issues, and in 1991, users were put on an allotment of 50 gallons per day per person. And as they pointed out, for a family of 4, if you adhered to that, your bill would be $72 a month. If you did not adhere to that, your bill would be more in the line of $450 a month. So they certainly used the financial hammer to do that. Now, you spoke of conservation. Oahu Board of Water Supply has lots of conservation tips on their website, including ideas on putting rain barrels outside to catch water to use it in the garden, planting low water use landscaping, instructions on how to check for leaks, and they give you free dye tablets to check for water leaks in toilets. The Maui Department of Water Supply is promoting conservation with conservation hints on their website, and they also give out free low-flow shower heads, faucet aerators for the kitchen and bathroom. And on the mainland, states are sometimes promoting conservation with similar programs and rebates for all kinds of water conserving devices. So 2 questions about conservation. 1, are you considering a water efficiency device rebate program? And then I'll tell you what the second question is.
Yes, so we've actually had preliminary discussions with our water board to see how we could set up a budget for that. Like anything else, you need to budget for it. But yes, we're looking at a rebate program.
And the conservation tips on your website, do you want to tell everybody what it says when you go to conservation, or shall I?
Go to our website and see for yourself. No, but
It says under construction. So basically, Keith,
we're deficient there, yes.
Yeah.
But you can go visit Honolulu Board of Water Supply for some great tips.
and you can, they're really very good websites.
No, but yeah, seriously, that is a sore point for, so as soon as we get done with all these questions here, that's another one of our things to do. And seriously, that was one of Kai's assignments, until we had a bunch of questions that came in recently about some wells in Kona that we've been having to spend quite a bit of time on responding. But after that, we'll have some time to focus on our website and
Kurt-
conservation.
Okay. Clyde mentioned power issues, and we had some questions about power. Do you have backup power on your wells? Do you have power surge protectors? I mean, I at home have my computer plugged into a surge protector because I know that a power surge would not be a good thing. So how do you protect your equipment? Should you be protecting it more? I know you addressed it, but I didn't fully understand. You sort of said a lot of things, but do you have power backup, first of all, and then the power surge issue? And I don't know if it's you or Keith that wants to address it.
Okay. In regards to, let me address the protection side. We do kind of a multi-layered, for lack of better words, because there's all kinds of protection that we're doing, from main breakers, overload heaters. The VFDs have electronic protection, and they can have hundreds of parameters, to protect us. I'll just name a few, but over voltage, under voltage, over current, under current, phase unbalance. There's a lot of things that the VFDs do. That's one of the other reasons why we like them. And in addition, doing the study that we have coming up to look at there we go. In addition, we have the study going on, and we're looking at multiple ways of improving our motor protection. We do have surge arresters. One of the issues we're looking at, we're trying to get a feel for the age of the surge arresters. As you know, well, I'm not sure everyone knows, but those MOVs have a service life. So if you have a surge arresters for your computers or your electronics, they do have a service life. And we're trying to get a handle on how do we verify if these surge arresters are still operational. So that's kind of an ongoing thing. That's in process right now as we speak. In terms of generators, Eric, we have what, 7 1-megawatt generators, was it?
We have 3 1 megawatt and 4 750.
750. I'm sorry, I got them mixed up.
We have 3 1 megawatt and 4 750 kilowatt.
And we recently got 2 400 and 2 200 kilowatt generators. So we're definitely working on that. But, having the generators is one thing, but you also got to have some of the infrastructure to tie it into the system. Otherwise, it's really a long manual process. And we're working on that also. So putting in transfer switches, basically.
Couple people asked, actually, on the website, can you guarantee that we will never have simultaneous well failures again with all the measures you're taking?
In short, no. So there's one, I don't want to give false promises. So things like never and forever, we really can't promise things like that. What we can promise is we're committed to being better. We're continually trying to figure out ways to improve. We're not perfect. These are mechanical devices. They fail. People work on them. People aren't perfect. So I guarantee you that we will do whatever we can, because we don't like to be in this situation any more than any of you out there. If we could make it easier and more reliable, believe me, we would have done it. But we are committed to making sure that we can minimize the potential of this happening again in the near future. How's that?
I'd like to add something to that.
Okay, thanks, Clyde.
I wanted to point, I'm not trying to make an excuse for us, but wells down at 1,600, 1,800 feet, or even 2,200 feet, like in Hawaiian Ocean View Estates, these are extremely deep-set wells. Typically, if you go to the mainland, most of the wells are under 1,000 feet. So we're in a territory not a lot of people are involved in. So we do have some reliability issues and challenges, but then we're kind of at the forefront. These are really extreme pressures, The only place you might see wells exceeding these depths are usually oil wells. At least that's what I'm told. There's not a whole lot of water wells that are at these types of depths. So we're finding there's definitely a lot of challenges. When I first started, when we first started these high-level wells repairs, we definitely had even more reliability issues in the beginning. A lot of these pumps and motors were coming from the oil industry, and they looked at reliability. They like pumps. They didn't have a problem with a pump lasting a year, but then they're pumping liquid gold, right, oil. So that wasn't an issue. But for us, 1 year is not really as bad. We want at least 4 to 7 years or more, if possible. So that's a challenge in itself. We're still trying to work out all the details of why these wells are failing. There's a lot of technical issues of why they potentially are failing. But as I said earlier, it looks like some of the smaller horsepower wells seem to be more reliable. So that's why we're kind of leaning that way.
Can I add something to that again, Sherry? So thanks, for that reminder, Clyde. And that's why moving forward, we pretty much have the 13 that we have. Going backwards in time, no sense we delve on that too much. But looking forward, that's why Kurt and Clyde talked about, issues came up about standardization, and we're all in agreement with that too. If as much redundancy or if we could use similar pumps and motors wherever we could, we're all for it. So that's why we want to make sure that our casing diameters are of a minimum size, that we do have that flexibility. If we're looking at 400 horsepower standard motors that can be interchanged with at least 2 or 3 sources, pumps maybe don't have the same thing, but like Clyde said, if we're within 5-10% efficiency and it's an emergency situation and we got to yank that, put it in another well, and just have to deal with higher electrical costs for several years, we'll do that as well.
I think you said, Keith, that the Department of Water Supply actually began in 1949. Is that the year you told me?
Mm-hmm.
So between then and now, are we having more failures now? Did you have fewer failures in the early years? Have you figured out, we've had failures in 2004, 2012. Is it happening more often? Give us your comments on that. I mean, what's happening now that wasn't happening then, other than clearly lots more usage?
Right. Well, so back in 1949, I was just a little bit younger than I am now. But no, so I really don't know what happened back in 1949. But the Kona system itself isn't that old. So right in this area, you guys have the benefit of a newer system compared to some other locations around the island. But like Clyde said and Kurt said, the high-level deep wells really only became part of our infrastructure in the early 90s. So those wells, apparently, if I'm not mistaken, Haliki'i was push-pulled how many times?
We had one incident where push-pulled at least 8 times within a couple-year period.
What do you mean by push-pull?
Basically
Down, up?
repair, back and forth.
Thank you.
So
Sorry.
in
We'll,
that
we'll all
regard,
be so smart we can come work for you guys.
yeah.
If I may, the simplicity, because I had to learn because of civil defense, not because of mayor. But, you all know this in regards to those wells in, as he said, a relatively new system. But my first question was, well, how come Hilo, Puna? Well, in comparison, the Hilo well is only about 200 feet deep. So you can see the major difference in the type of pump and problems that you have.
A question about the future. One of the things that you all remember is Keahau Aquifer, and during that time, we heard a lot about the water that is underneath here. The Keaho Aquifer really encompasses a larger area than just the North Kona water system. I think it goes from Hokulia in the south to Makalavena in the north, up to the top of Hualalai to the ocean, whereas the North Kona water system that we're talking about is between Makale Fire Station and Tashima's, roughly, and Kona Airport. So under the Keaho Aquifer, there's, according to Roy Hardy, who's with the State Water Commission staff, and by the way, is pretty much the smartest guy I've ever heard from relative to water, not as smart as these guys, but he is magnificent. And if you really want to understand how the State Water Board controls water in the state, including on this island, you should absolutely go back and listen to interviews I did with Roy Hardy. You can get them at lava1053.com and just scroll back till you find them, because that was the beginning of my education on water. And he said there's 150 million gallons of water in the Keaho Aquifer, 150 million gallons of water per day going in as what they call recharge. The state has set the sustainable yield, meaning the amount of water that can be taken out every day, at 38 million gallons of water a day. 38 million. Got that, Max? He's not listening to me. He's got his headphones in. He said 38 million on Monday, and it got printed in the paper as 30, but 38 million gallons of water a day. The amount of water we're using today is 15 million gallons a day. So we're well under the sustainable yield. So Keith, the question is, you updated, the Department of Water Supply updated your complete water management plan, and that included a look at the future. So right now, we have some issues here in North Kona. They will be solved, I'm assuming. But what about the future? Are we in jeopardy looking at future development, given what is planned?
Yeah, basically, we're very comfortable with the planned future development. So part of our update of the water use and development plan included whatever we knew that was had some form of approval in the approval process, whether it be the general plan, the Kona Community Development Plan, if it had a water commitment from our end, if there was an existing service lateral, if there was some kind of water development agreement where we entered into an agreement with a private entity to set aside certain amount of water units based on their participation with us on source. So basically, we looked at whatever we had under the sun that had some level of approval. We added up all that, the anticipated water demand from those supposedly future water users, and all that added together, we're still in a safe place compared to the sustainable yield. So of course, we all understand that development, you don't get full build out overnight. So we compared that with, a reality check basically, compared that to population growth, 1 or 2% per year, something along those lines. And even, wherever those two intersected, we're still well below, well, not well below, but within the safe zone of the sustainable yield. So we're very comfortable with future development and what's been coordinated through the general plan, community development plans, and things like that.
Okay.
On the county government side, the Department of Environmental Management, our goal is to, on the wastewater, to level 1. In other words, that water can be used for irrigation and farming as well. And naturally, we will get there, but we need time to get there.
And it's really a separate subject, but if we can use the wastewater to water, to provide to whatever needs to be watered, like the district park, the Kealakahi District Park that may happen along one day, or right now, Old Airport, is that something that we're going to push for in the county, Mayor Kim, to be able to actually provide the pipes to ship that water from the Kealakahi wastewater treatment plant down to where it's needed? Because I understand right now the water will be treated, but there's really no way to get it out to the places it needs to be. So tell us what the plan is, please.
Not obviously, thank you, Chair, because transmission of everything. Power, including water, is always a part of the problem. And that has to be built in because initially the water was to be used for entire irrigation for anything along the Queen Carmona Highway. Where it is today and what the goal will be, I cannot give you a real update on it. All I can tell you is that is our goal of Department of Environment Management to go to level 1 so it can be used for irrigation.
Kurt, you look like you wanted to say something.
Yeah, just so happen this slide is up there. It does show the county's participation, the Department of Environmental Management in the Queen Kahumanu Highway widening project that's currently ongoing. They do have, pipes going in with this project. Oh, it's already installed, basically. So we also have a water line as well in there.
A question about the pumps. Do we have one vendor that provides these pumps, more than one vendor? You put these out for bid. Do you actually, I'll use the word, are you sole sourcing essentially because there's only one company that can provide? Are there multiple companies? Tell us more about that.
There's 3 pump contractors out there, but we're primarily getting bids from only 2 of them, at least the ones that we've worked with in the past. Yeah. Oh, I'm sorry, the pump manufacturers? Oh, I'm sorry, I thought you were talking. Okay, pump
How
manufacturers.
about all of the above?
All the above? No,
I
they're
mean, the
not.
question was, who are the pump vendors, and how many vendors can provide the pumps you need? So, just tell us about that.
There's definitely a limit on the pump manufacturers because, due to the high pressures. But let's see, we work with Simflow, National Pump, Byron Jackson, any others? Maybe Gould's? Yeah, there's a handful of manufacturers that we've dealt with. I mean, there's more out there, but we get fair competition. Motor manufacturers, there's at least 3, Sunstar, SME, Byron Jackson, on these larger horsepower application, and a lot more even for the smaller pumps and motors.
Keith, at one point you said that your hope was that wells would last, or the pumps would last about 7 years. And clearly you've had these failures at way shorter times, and you said you're still working on figuring it out. And Clyde, you really did speak to this, but how are we doing on really figuring it out? I mean, what sense do you have at this point as to why it's happening so soon? Because many of the questions that came in say, well, couldn't we just order things in advance, or couldn't we order spare parts? But it sounds like if you're having things fail in 6 months or a year or 2 years, you just be ordering equipment all the time. So tell us more about that.
Sure.
He's hoping it's a very undirected question, but
No, it's a tough one because I think you hit it right on the money. Is trying to find out all the reasons and be able to fix the pumps and motors. But like I mentioned earlier, there's so many types of failures, and it's not like the seals are failing in all the pumps. Then we can address that. But when you get multiple and the failures are all different, it becomes much harder to troubleshoot. That's why I was saying earlier, that's why we're looking at possibly going smaller. At least there's certain things that we know that are happening. The smaller ones do last. They tend to last. Not all the high-level wells, have historically been short, but in general they have. But we do have some wells, that we got 8 to 10 years on. But, historically it's been under 7 years. But we're trying to consistently keep it at that level, at least 7 years. That's more reasonable, and that's what we should expect from a pump. It's about 7 years.
you mentioned that the equipment for the Palani, Hualalai, and Keaho, or Keopu wells are going to come in August, and you had completion dates up there by contract, but you said you were hoping to get them earlier. Any sense as to when earlier might be? Or do you not want to commit, because then we're going to hold you to it?
No, there's a lot of factors that go into it. We can give you a tentative, but there's a lot of things that might happen that could change that. It's really hard to set a hard date. because we know things happen, whether the manufacturer runs into a problem, or the shipping company, or there's delays on the pump manufacturer, or there's a lot of things that could go wrong. Murphy's Law seems to apply a lot. If it could go wrong, it does. So, I'd like to commit to an earlier date, and it looks like it's possible. I'm being optimistic. I'm just hopeful that I feel confident it will be earlier, but how much earlier has, I reserve comment, I guess.
The fifth well that failed, why did that fail? Do we know? The last well, the fifth one.
Okay.
The one that was only out of service really for a couple weeks.
Well,
Do we know why that one failed?
we know some of the symptoms. We know what happened, but it's under warranty, so it's basically got to go back to the manufacturer, and then we're going to determine. Well, they're going to determine what they think is a fail. Yeah, I can tell you what we saw, but whether that we don't know the exact cause yet because it hasn't been torn down. We just see the results.
So what was that?
For example, we feel pretty confident the thrust bearing failed on the motor, and there's a lot of things that can cause a thrust bearing to fail: overload, overheat, water hammer, reverse spinning, lack of lubrication. So without tearing it, we haven't looked at it, but we can see the results. We were pretty sure that the thrust bearing failed, but it has to go back. We got to go back and have the manufacturer tear it down to say if it's under warranty or not, and make a report for us.
Did you want to add anything, Keith? No.
No, but basically, yeah, so I think we've explained this before is, like Clyde has mentioned, we need to keep these manufacturers honest and responsible as well. So we've, at certain points, had Clyde or somebody else fly up to witness this tear down procedure. Not that we don't trust them, but we just wanted to make sure that everything is above board and things like that. So it's like Clyde said, although you can tell what part broke, oftentimes it's not real clear why it broke. Anyway.
We understand that you said that the funding to fix all these wells is already included in what we have been paying in water rates. Have you looked into getting grants? One questioner asked about a USDA Rural Development Emergency Community Water Assistant grant, but there are other grants out there, so tell us about that.
Yeah, so we've been, actually for these well repair jobs, basically it's been coming out of our regular operating budget. We have had some experience with that USDA emergency grant with the Pahoa lava flow situation from a couple years back. We tried to explore the opportunity to utilize that grant on a repair of one of our Pahoa wells. My understanding was it didn't meet the criteria for some reason. There's a lot of strict and stringent criteria that go along with these grants. So although they often say, hey, this is available, you need to really meet the criteria for them to really give you their blessing and the funds.
Well, this particular question came in on the website, and so I looked up the USDA Rural Development Emergency Community Water Assistance Grant, and it's only available to communities of, I believe they said 10,000 or less, and the income requirements of the people in that community have to be pretty low. So my guess is for what you're looking for now, North Kona probably would also not qualify, just based on what I read. I'm not an expert, just read that. Another question that came in is about compliance with fire guidelines, and the questioner asked about the National Board of Fire Underwriters guidelines, but so I called the fire chief to ask about that. And what we use in the county is we adhere to the National Fire Protection Association guidelines. And he said their state and county and all the fire departments here work together. And then the question is the water department on board? And I would imagine the real source of the question is, if there's a fire in North Kona, is there enough water to put it out?
Right. So yeah, a couple parts to that question. I'll address the last one first. Yes. So even with the current situation we're in, our guys are maintaining a minimum level of water in the tanks. And based on our water system standards, and Kurt can probably elaborate on this a little bit more, the highest level is for a commercial development, which requires 2,000 GPMs for a 2-hour duration event, which equates to 240,000 gallons. So for our water tanks, the main ones servicing these areas, our guys have determined what those critical levels are, and we're maintaining those levels. Like Mayor said, we're always in communication with our fire department. We're on the same page with them, and even going back to the standards. So maybe can you explain about the standards?
The standards, it's developed statewide, so there's a fire section in the standards anyway, fire requirements, fire protection requirements. So that has been developed with the input from all of the counties as well as the state. I think there's like a fire prevention bureau or whatever, that we get together and put together these standards that actually the fire departments have basically set, and we include it in our water system standards. So when there's a development of a water system, depending on what kind of development is going on a particular property, we have the standards that they need to meet, or our system needs to meet anyway.
Just as an aside, by coincidence, yesterday I had the fire chief at the radio station because we were talking about the Sayer Foundation, and I asked him the question about, are you concerned about us having enough water if there's a fire in North Kona? He said, no concern at all. When we have a fire, anytime we go to Civil Defense and Department of Water Supply, we let them know where we are, what we're doing. They guide us in what, hydrants and wells to use. So the fire chief was okay. And for me, that was enough, just FYI.
On that, Chair, just reassure the listeners here that we do have the water tankers all identified as far as capacity, where they're located, and move them around as necessary. So if there is a fire, we meaning Civil Defense, are notified, and there's a fire personnel in the EOC to coordinate that.
And here's a question that I apologize should have been asked sooner, which is, would you define basal source? And I apologize, because that's sort of a basic thing.
No, I'm just kidding. The basal source is basically, the fresh water sitting on top of the salt water layer that we trying to capture, obviously, the fresh water and bring that up for consumption. But with the increased pumping, as we saw, it was what they call, what is it?
Upconing?
Upconing of the salt water.
You get salty
lens.
water.
Yeah, so
And the basal sources are the ones that are sort of more towards sea level, right? A little lower down on the mountain?
Actually, in this region here, we found basically the Mamalahoa Highway, the upper Kona Road. Anything below that, we're probably in the basal lens, what we call the basal lens. So there's some form of structure, geological structure that's preventing the fresh water from just seeping out into the basal lens. There is some occurring, so there is, fresh water on that salt water in that basal lens, but it's a much more finite amount, a limited amount. And the rate that we can extract it is limited.
Have you heard of other islands having similar problems with their pumps and wells, failures like we're having here on this island?
I can at least say I know we've searched, and we are very unique. I don't know that there is another well in the state that's similar to what we have as far as the high-level wells here. Done a search on the well database, basically, which with seaworm, just to, we're trying to see if there's anybody out there that we can see if they have, again, spares that we can share or we can borrow, whatever it is. But, there's not much out there that's similar to what we have here.
Sheriff, if I may, if you saw me sidebarring with Keith here, I was asking him to refresh my memory on the Hawaiian Ocean View Estates people worked for years to get the money for the water well in their subdivision. And finally, the state appropriated them $6 million for that one well. And Keith wrote down that they draw only And it's not high quality, 70,000 gallons a day. I thought it was closer to 100,000. And you can see one well, it's a geological region where the water beyond South Point, it just doesn't go there. And so we'll never get good well water from in that area. So that's why I asked him the question about beginning a study to see what it will cost to transport the water from the east side.
A gentleman in the audience, Barry Willis right here, said that he has a proposal to suggest alternative means of getting water, such as shipping it from East Hawaii to West Hawaii, drilling canals on Mauna Kea, things like that. And he wanted to make a 20-minute presentation, which clearly we don't have time for, but I will give you his material, and then perhaps you can get back with him and discuss that with him. Our spare parts inventory, are we able to maintain more in the way of spare parts than we do now, do you think?
Yes, so as Kavika mentioned, what we're doing is creating a priority list. So we've already created that initial set of priority lists, spare pumps and motors. As Kavika also mentioned, we've gone through the procurement process for the first 3. We'll implement the procurement process for the next set, another 3 in the next set. Again, basically, those spare pumps and motors, like was mentioned by Clyde earlier, we don't have the resources available to provide a spare pump and motor set for each of our 60-plus wells. So what we're trying to do is establish a priority system, one, based on if it's a sole source in the area, 2, if there's any possibility of interchangeability between that pump and motor set and another site, and 3, if it services a critical facility like a hospital.
Somebody wants to know what it takes for them to dig their own well. Do you want to address that, Keith?
Go for it. It's a lot of fun. No. So there, I'm sorry, I joke, but
But it's
there's a
actually
lot-
correct. You
there-
can go for it if you're an individual user.
Yeah, you can. So in Paradise Park, in fact, that has been explored and been done in HPP in Puna. So those are, of course, much lower capacity. And in Puna, in HPP, much lower elevation. I think we're talking on the order of what kind of horsepower for one of those individual wells?
I haven't dealt with that.
10
They're-
horsepower.
I suspect they're fairly small.
10 horsepower,
10
maybe
horse, I would
25 GPM. But there's other well drillers, not the ones that we use, that you can contact. I'm not sure who those are, but
I know Derek's does some of that.
Derek's does some of that.
Derek's
Okay.
well drilling.
Diamond drilling.
One of the sources that you should really use if you're interested in knowing way more about water is go to the State Water Commission website. It is fabulous, and I mean fabulous. During the Keauhou Aquifer time, they loaded it up with information, all the hydrologist reports, everything they knew about water in this area. It is really magnificent, and I highly recommend it. And part of what Roy Hardy and I have talked about in our interviews is just that individual users can build their own wells if they want. And as I mentioned, there are 5,000 wells on Hawaii Island. In the Keauhou Aquifer, he said there's around 100 wells. Only about 50 of those are actually being used for production, pumping water out. But there's a lot of information. Now, Keith, are you monitoring for salinity and such in your wells? And if people want information on that, how might they get it?
Yes, maybe Kavika can address that.
Yep. We do routine monitoring for chlorides and sodium levels in our North Kona sources, and actually that information is available on our website right now. It's current as of now.
Even though the conservation part of your website is horrible, the rest of it's really good, so it is there.
It's under the About the Water tab, water quality.
Yeah.
And people can also call you and find out about hardness of water too,
Sure.
yes?
Yep, you can call our water quality branch, 961-8670. We can provide that information.
We have about just a couple minutes left. I'd like to give you guys an opportunity to say anything in closing. A lot of the technical questions I believe you answered during your presentations, but I know you will be here if people want to ask specific individual questions. And also, you can call these guys on the phone because they're pretty responsive, and send them emails. So before we close, Kavika, final?
I just want to, again, say mahalo to everybody through this duration. Thank you, everybody, for your cooperation and help.
Keith?
Yeah. So like Sherry mentioned, give us a phone call. Really, if you really want the best available information, please give us a call or send us an email. And if we don't know it right then and there, we'll get back to you for sure.
And your website is hawaiidws.org, I believe?
Correct.
Okay, hawaiidws.org. Kurt, anything final you wish to say?
Just repeat the thanks for the assistance during this time. It's been challenging, but I think we'll hopefully both of us will learn our customers as well as our department and get better from this.
Clyde?
I've been getting calls from the local community, mostly engineers. But I'm definitely open to ideas, and I appreciate those efforts trying to help us out here. We're basically here, we work for you. You're our customers, and, we take pride in that, and I just wanted to emphasize how important you guys are to us.
Mayor Kim?
I hope you feel a little better about who works for you. I really trust these guys. They're good, they're professional, and they got only one mission: to provide you good water. And when you pay your bill this month, I hope you feel a little better about it.
But pay that bill. Thank you very much for being here. I'd like to turn it back to Bill Bugbee, who's with the West Hawaii Forums Group.
Thank you, Sherry, and thank you all for coming. I wanted just to say you have a survey with your program, and if you'd be so kind as to give us your thoughts and feedback. We have an open forum slot in the fall, and we'd love to get your ideas on that. And presuming we have no more crises, to have another forum on water, we hope to cover some other subject matter this fall as well. Our September forum is going to be studying and looking into the situation of healthcare on Hawaii County, which is an ongoing challenge for a lot of our citizens, as well as access to family physicians and what have you. We have a very robust panel for September 21st, I believe it is. And then in November, we're going to be doing a forum on sustainability. And by that definition, we're going to be talking about how we, Hawaii Island, living in the middle of the Pacific Ocean, can be more independent sustainably, not only in energy, but also in food and everything else that's essential to day-to-day living. So I recommend you come and attend both of these forums, and then give us some ideas for the October slot. Beyond that, wish you all a great evening, and thank our panel again for coming. And I would say that from my point of view, I learned an awful lot tonight. I hope you did too. Thank you.
This is the representation of the kind of quality of speakers that we have here at West Hawaii Forum. And we put these monthly forums on to provide as much civic involvement and education on issues that are important to you, the community. We are one island. We are one community.